Cool. Thank you very much. Hi, everyone. This may not sound like the most glamorous talk to start with, but it's an area where localstack has had some issues in the past. We get reports from users about connecting their applications to localstack. And as I mentioned, I've been working or leading this initiative for the last 9 months or so. So hopefully we'll see a big improvement together. So if I start at the beginning, networking, conceptually, it can be quite hard. Networking is the user experience I find is not great when things go wrong. So you quite often get things like timeouts or cryptic errors from deep dependency libraries like OpenSSL, for example. Typically, the tooling that there is to work with networking can be quite platform specific. So there are different tools for macOS to Linux to Windows. Typically, the tools are older and as well, and maybe not as easy to use as some of the more modern tooling that there is for other aspects of computing in general. A lot of times the settings that you may want to play with to access things like DNS or VPNs are locked down by system administrators. So it's not as flexible and easy to change as you might like. There's lots of acronyms. I've got some in my notes. There's like HTTP, DNS, TCP, UDP, IP, VPN, VLAN. It's a lot to keep track of. It's a lot that I don't know what they all mean, certainly. And when you add Docker to the mix, that brings some additional complexity. Again, this networking Docker works by isolating processes in namespaces. That's a bit confusing. There's lots of virtualized Ethernet going on and everything. So all in all, networking is a bit difficult, and I certainly have learned a lot coming along this journey as part of localstack. So let's have a look specifically at what localstack does to interact with the network. So I mentioned Docker before. Localstack runs in a Docker container. So this means that it's got its own networking system within the container that's sort of shared with the host, but sort of not. I might go into further details later on. It uses an operation called publishing, port publishing. So this is saying that I'm going to say that port 4566 on my host computer connects directly to the Docker container. And this is how we get traffic into and out of that isolation system that Docker provides. As part of our localstack internals, we use Docker containers ourselves to run background processes or your application code, for example. So if you were to run, say, a Lambda function, that runs in a Docker container. And all of the inter-Docker communication has to be sorted out. And this leads to some very complex networking requirements. I mentioned even just regular networking on a single computer is hard enough. When you add Docker to the mix, it gets a lot more complicated. So I'm going to now outline a few common problems that we have either experienced ourselves or observed from my users. They're not specific to localstack, but we rely on these features to work as part of a functioning system. So there's this idea of port publishing. So what happens is when you publish a port from your container, there is a process called the Docker proxy that listens on your host system. This acts, as it says, like a proxy, and it sends requests from the port that you've published to the container, and it handles the reverse direction as well from the container back out again. But each interface, technically, so your local host interface, can only have one port assigned to one program. So, for example, it's more, should you wish to, you can't run 2 copies of localstack with its default configuration because there's already ports bound by this Docker proxy. More kind of relevantly is that you might have another server listening on a port, and you can't have 2 servers listen on the same port, for example. As a part of the way AWS works, AWS is centered around sending network requests. AWS itself uses subdomains very heavily. So, for example, I've got here the subdomain way of addressing an S3 bucket. So it's the name of the bucket .s3.region.amazonaws.com. Localstack does something very similar. We use subdomains in the URLs of requests that are made to localstack to send those requests to different services to make sure that we are handling the request correctly. And another aspect that is a common problem is TLS, so HTTPS communication. It requires a certificate of a proof of ownership almost that the server is correct. or the server owns that domain name, and that's not always easy for a local development like this, like localstack is really is really suited for. So as part of this talk, we're going to walk through a problem. It's an example application that I've set up. It's a very simple application, but it's kind of representative of some of the situations that users have come to us with questions and issues, and we have tried to resolve as part of this initiative. So I'm going to switch to my terminal now. Hopefully this is okay to follow, but what we have on the left here is two files. So the bottom file here has a little diagram of what we're going to build, or what I've built as part of this demonstration. It's within a Docker network, and it contains two containers. I've got the localstack-docker container, and I've got my application Docker container. The application is going to be interacting with localstack as if it were AWS, so I can develop my application as I go along. Make this a little bigger. And if we kind of drill down into the details, here we see this is Docker Compose. Apologies if you're not familiar with Docker Compose, but it's a declarative way of stating which containers I want to run in their configurations. So at the top here, we have a localstack container. This is pretty much copied and pasted, I think, exactly from our getting started quick start guide. If you were to look up if you go to the localstack repository on GitHub, you'd find the Docker Compose file that looks like this. Nothing unusual. At the bottom here is my application container. So this is my kind of business logic. This is the thing that I want to interact with AWS. So I've set a few variables here for the environment. They are to configure AWS clients. It's just to save me specifying too many things. But the key part for this application is that it's going to be listening on port 5000. So specifically, Docker is going to publish port 5000 onto my host system. And this is so that I can interact with the application from outside Docker. The application itself is this file at the top here. This is in Python, and it's using Flask, which is, apologies if you don't know Python or you don't know Flask, but it's a web server library that you can use to create simple web servers. It exposes two endpoints, health and queues. Health just exists for me to check that it's working. And queues is where we're going to be focusing on. So in the queues endpoint, what we do is we use this client object. This is part of the Python's AWS SDK, how we interact with AWS day-to-day in Python. And it's created up here. So we don't provide any arguments. We're expected to take things like credentials and the AWS region that we're operating in from the environment. It's a fairly standard way of interacting with a language SDK like this. All of the configuration normally is read from the environment that the code is running in. So what we do here is in our queues endpoint, we list all of the SQS queues that we have in our account in this particular region, and we're just mapping the result to make sure that there's something to show. Not very interesting. And then we're returning that as a JSON object. So throughout the course of this presentation, you'll be seeing me run this code in different versions of it. And I'll be doing that in the top right here. So I'll be running it with this command, docker compose up. So this launches these two Docker containers. And I'm also adding the -- build flag just to make sure that if the container needs rebuilding, it gets rebuilt. And you'll see output in both yellow, which is the local stack logs, and you'll see output in blue, which is the application logs. The specifics of this pane don't really matter, but it's there for primarily me to make sure that everything's working. What I can do now is interact with my application. So I mentioned it's got two endpoints, health. I can make a request against the health endpoint, and that tells me that the application is up and running and it's working, at least as far as the Docker container is concerned in the networking. Let's see what queues there are in my account. I mentioned we're doing this list queues operation as part of this handler, so now let's invoke this. And we get a nasty looking error. This is unfortunate. This is because I mentioned that the AWS client takes all of its credentials from the environment, which is what we've defined down here. So access key ID and secret access key. These are not valid values. So unsurprisingly, AWS is saying, no, you can't list the queues in your account. So faced with this issue, what I want to kind of emphasize as part of this work is the first thing that we did as part of this initiative, which was to build out some documentation and troubleshooting guides. So what we created in our documentation, there's a link here and we can circulate the link afterwards, is a series of scenarios that a user might be faced with when they're dealing with localstack, trying to connect to localstack with their application, so on and so forth. And we created these little schematics and pictures. So let's go through the process of trying to troubleshoot this networking problem. So we're not using a resource created by localstack. We're trying to interact with localstack directly. And we're using a language SDK. So we'll go to this panel on the left. And we're accessing it from our container. I'll talk about some of these other situations later on, but at the moment we're focusing on from our container. We would click on this. I happen to know what the guide tells us. So let's go back to what I've been calling internally the seamless connectivity. This is now where we are with localstack 3. This is current implementation of how we improve the situation for our users. So I'll switch back to the terminal. To save me typing, I've made all the changes in a Git repository, and I'm just going to change branches, and that's how I'm going to make the changes because I don't want to type in a live demo. So I was on branch demo 1. Now we're going to go to demo 2. So I can tell you the solution that the guide tells you is to try and use the domain name localhost.localstack.cloud. And we'll see that if I check out this branch with the latest changes. What we can do is we can see the change I've had to make to my application is now the SDK client takes an endpoint URL parameter. This is saying every request you need to make to what you think is AWS, send it here instead. And I've specified localhost.localstack.cloud. Now as a bit of a kind of demo, I'm going to show you one of those archaic tools that I mentioned at the beginning of this presentation, which is I find particularly not friendly to use. I want to know more about this localhost.localstack.cloud domain name. So I'm going to use a tool called dig. I can't remember why it's called dig, but it is. And we can investigate more about the domain name localhost.localstack.cloud. When we do this, we get a lot of output. I can tell you a lot of it doesn't matter. It's kind of unintuitive, but the thing we're interested in is this section here called the answer section. It's kind of confusing, but the answer section tells us that localhost.localstack.cloud maps to the IP address 127.0.0.1. So you might be asking, well, how are we able to use this domain name 127.0.0.1 in our application container? If I go back to the top here, the application is not running localstack on its local address. It's in a separate container. It's got a separate IP address. So how does this work? The way we've implemented this is we have introduced a DNS server. So DNS being the domain name system. It maps, as we saw here, domain names to IP addresses. The DNS server that's running in localstack will, for a select number of domain names, return the localstack container's IP address. So if I were to make a query from the application container, which I can do if I start the application, I can run docker exec, docker compose exec app. So this is this application, and I can spawn a bash shell inside this application now. It's running. I can do again dig localhost.localstack.cloud. And previously this returned in the answer section 127.0.0.1, but now it's a different IP address. Where does this IP address come from? So I mentioned previously that the DNS server responds with its own IP address effectively, the IP address of the localstack container. So the application says, before it makes any request to AWS, it says, can you give me the IP address for localhost localstack.cloud, please? And the DNS server will say, okay, my IP address is this 10.0.2.20. I'll return that. And then the application with the configured AWS SDK knows to make requests to the localstack container. So with this small change in our application, we're able to connect to localstack fairly straightforwardly. I can show you this if I curl the queues endpoint again, and we see we have some queues. What's really useful about this is on the host, I showed you localhost.localstack.cloud resolves to 127.0.0.1, and port 4566 is published to the host. So we can add a queue from the host. So we're not inside the Docker container here, we're on my host system. I can run sqs create queue, and I'm just calling it foo. Then I can interact with my application, and it lists my queue. So we've got connectivity to localstack from outside the Docker ecosystem and inside the Docker ecosystem. This doesn't come quite for free. There are previous versions of the networking guide before we implemented this DNS system that mentioned things like if you're inside a Docker container, inside a Docker Compose stack like this is, you can address containers by their name. So rather than localhost localstack cloud, I could have used localstack, but there are downsides and problems to that made us look a bit further. So we wrote the documentation guide. We realized it wasn't quite complete, didn't give us as seamless a connectivity as we wanted. So we continued to work and implement this DNS-based system. We are going to be publishing a blog post very soon with more details about the initiative and the kind of the advice for where we're going, and also how this system works. So look forward to a blog post on our blog coming up very soon. So this is good. This gets us connectivity between our two Docker containers. So it also, what's really nice is it also supports. So I was talking about DNS. So one of the challenges that I mentioned earlier is that subdomains are very important to AWS, and they're very important to localstack as well. So one of the nice features of our DNS resolver is that we resolve every subdomain of localhost.localstack.cloud to the localstack container as well. And I can show that off by going back into the container. I've restarted it. Unfortunately, I'm going to have to rebuild the container now, so I'm on a different computer now. I do apologize. The fun of live demos. So when the container runs, I'll be able to make a DNS request against the localstack container for subdomains of localhost.localstack.cloud. So let's see that working. Okay, so I can do dig bucket.s3.amazon localhost.localstack.cloud. It still responds with the IP address of the container, 10.0.2.20. There is some configuration that has to be done on the user side now. So on the environment of the application container, there are a few changes that need to be made. So the first is we need to tell our application container to use localstack as its DNS server. And the way we do this is with this DNS entry in the compose file. So we can set this to be a list, in this case, one of DNS servers that we're going to use to resolve localhost.localstack.cloud. Here I've put the IP address of this is the localstack container because we need to use localstack as the DNS server. And I'll tell you how we get this value later. In order to do this, we need to configure the user-defined network for Docker. So when you put containers in a Docker Compose file, they become part of the same user-defined network. And user-defined networks have got a lot more power and configuration than the standard network does. When you start a Docker container without specifying any network, it gets put in the default bridge network. But that's static and not very configurable. This is a user-defined network, and we've called it LS for localstack, and it provides extra configuration. The one we need is to give the local stack container a fixed IP address. So in our local stack config, we're saying that the local stack container belongs to the LS network and it has this static IP address. And then the final piece of configuration we need is to say that the Docker doesn't allow you to assign a static IP address like this to a single container. You have to define what's called a subnet, or a range of IP addresses that Docker is able to choose from when running containers. So in the network configuration of this LS network, we see we're defining the subnet to be 10.0.2.0/24. I won't go into details, but this means that anything that starts with 10.0.2 is in the same subnet. Docker will pick an IP address out of this IP address range to assign to the app container. So that's how we get the two Docker containers in the same Docker network and the same subnet that's implicit as part of the Docker network. And one container is able to talk to the other. Let's see what else we can do. I mentioned the subdomains work, but what about, there was another item on the list. So we've got subdomains, we've got no ports are being published to the host. This is all done within the Docker network, so we don't have any port conflicts. Something else that was mentioned in the problems was this idea of HTTPS and valid certificates. So it's very hard to generate a certificate for localhost. I think it's somewhat frowned upon, apart from local development and that sort of thing. But if we check out the next stage of my demo, what's changed? Now you can see that we're using HTTPS to connect to localstack. So again, we've got the domain name resolving from the DNS server as part of localstack, but now we're able to use HTTPS. We have a trusted certificate for localhost.localstack.cloud and subdomains that we can use to present a valid trusted certificate to any clients like this Boto client. You'll see the port has gone as well, and that's implicit. HTTPS by convention is done over port 443. If we have a quick look in our compose file though, this I want to emphasize how this is working, but we're not exposing port 456, we're not exposing port 443, we're not publishing the port. This again, to emphasize, is all the traffic is going over the Docker network. It doesn't care about ports published to the host, that's separate. We're able to make that request against port 443, even though we're not publishing that port. The configuration change we've had to make was another aspect of this networking initiative, was to streamline and improve the configuration for localstack. So before the initiative, for those of you who've been using localstack for a little while, you might have remembered variables such as edge port HTTP, edge bind host, localstack host name, and host name external. Those variables, they had a mixed role within localstack. Some were used to configure the container, some were used for what I've been calling cosmetic purposes. We'll go into more details as part of the blog when that gets published, but for now, we're able to use this environment configuration variable gateway listen to tell localstack to listen on both 4566 for the host and 443 for the container, for our application container. That's not how you type. So I can run this new stack with HTTPS in our Boto client, making requests to localstack, and we get a valid response. So everything's working again. Now everything's actually encrypted, all the networking traffic. This is local and perhaps not the most important thing, but it emphasizes that this is showing the maturity of this networking implementation as well. The final thing I want to demo very quickly, because I think I'm running out of time, is a change that was actually provided to us by AWS rather than ourselves, but it's something that we are making use of in localstack. So if I take a look at demo 4, the application itself has returned to its original state. I can show you this if I diff the first state we started in with the state that we are now, scoping it just to this application file. The code, okay, it's not quite the same. I've made some renaming, but the code is nominally the same. The client setup is exactly the same. We're not configuring the client. It's all done through the environment. recently AWS introduced an environment variable called AWS endpoint URL, which is used to configure some client SDKs. Depending on the language and depending on the version, you may find your applications will work like this. You can configure this environment variable to point to localhost, to point to local stack, and then your application code. This is the same as what you'd write on AWS. It's a really cool time to be working with localstack at the moment, because you get this. The changes you have to make to your code to make it run on AWS versus localstack is getting smaller and smaller, and I think that's really exciting. I should mention that if you're using some of our runtime environments, so particularly Lambda and ECS, we inject this variable for you. So you don't have to, if you're using an up-to-date SDK with the right language, you don't have to change your code again if you're talking to AWS resources. We'll inject this AWS endpoint URL for you so that the clients know where to make their requests to. So now if I switch back to the presentation. So if we go back to our list of issues that we had at the start of this talk, we had only one process can listen to a port and an interface at once. This is the port publishing problem and port conflicts. Well, this is now gone. If you're happy to work with container-to-container networking, you don't need to care about port conflicts. Trusted TLS certificate cannot be created for localhost without configuring a host system. This is also gone because localhost.localstack.cloud is used throughout, or if you use localhost.localstack.cloud throughout, TLS certificates can be used and HTTPS traffic could be used. And finally, AWS about subdomains. I mentioned before that subdomains of localhost.localstack.cloud also resolve to the localstack container. So in summary, this initiative has streamlined the way that users' code connects to localstack. Hopefully you've seen how much more straightforward the application code was. There are reduced differences in application code. So again, that parity between your code versus localstack versus AWS is getting closer and closer. We have the network troubleshooting guide, as I mentioned, if you have any problems. The networking component is open source, the DNS server. We welcome contributors for that. And we have our community Slack channels and other ways to reach out to us if you have any questions. And as I've mentioned, there'll be a blog post with more details coming out very soon. Just another mention of the network troubleshooting guide. And finally, next steps for me. So at the moment, I'm currently looking into networking, but also increasing our support for other container runtimes. So I've mentioned Docker a lot in this talk, but there are other container runtimes such as Podman and Kubernetes. We're looking quite heavily into increasing our support for those runtimes. Part of the networking initiative, we're looking at TLS certificates in more depth. So we have our certificate at the moment, but we're looking at dynamically generating and dynamically trusting as part of localstack's operation. And in the more distant future, we're looking into more accurate EC2 networking primitives and emulating their behavior. So subnets, security groups, VPCs, so on and so forth. And that's it. So thank you very much for your time.